Hi, this is Heath from alphahpg.com. I'm currently setting up a lab for my own CCNP studies. First up, I'm going to be building the core MPLS layer. Now, in the CCNP, it doesn't actually require you to actually know how to configure MPLS, but it requires you to understand the basics of it. And to be honest with you, that's just fact. Um, you should have a basic understanding of how to configure MPLS, as it makes it easy to understand the whole process of how traffic flows around and so forth. So what I've done is I've created a little pentagon style shape here with 4 core routers, and off of them there's going to be a P of each one. Now this will give us some interesting results, and I'm going to be adjusting some bandwidth levels here and there just to make the OSPF routing a little bit more interesting. And I will be adding some additional links across. I think in my notes I got call 1 going to call 3. Yes, I do. Okay. Alright. Let's start with config for call 1. Now, just to give you an idea of the basics of what I'm going to do to for the IPs, I'll put this window up. I haven't done this one, and it's perfect. Okay, so can you read it? Yes, it can. Okay, it's pretty neat. Let's just expand it out a little bit. Okay, so it's that section there, the top part. So core routers are on subnet 172.162.254.x/31s. Core PEs are on 255.x31s. Loopbacks are on 192.168.255.x/32. And PEs are on .254.x32. Okay, so as you can see down here, I've got the core linked core 5 listed as a bandwidth of 100 meg. Now, I'm using the older viral images to give to make this work, as they're fairly lightweight and they've got pretty much all the requirements. So let's get on to it. So let me just hide this and bring this up. Okay. Alright. So let's start with, there we go. Classic conf T. We'll do the loopback interface first. Now, I really wish that in the iOS XE and the standard 15 images, they would actually allow you to do the slash notation versus the fucking 255s. And if you just noticed, I didn't scroll. Okay, cool. I was thinking it was the length of the PE, but that's all cool. Okay, now let's do the interface to the PE. And no, it's awkward. It's a point-to-point link. Okay, now do the linked core 2. And disk 1. Core 2. Type tonight. Add. What I'll do 6.254.0. Okay, yes, we know. Okay, we want oh shoot, I screwed up. This should be .2, because this is the point link to core 5. Description. Okay, cool. All right. This is the one to core 2. Dumbass I am. Disk core 2. And 172.168.55.0. Really? I changed that. Unsigned. Okay, yeah, dumbass. 4. That's what it should be. Okay, so there we go. So we've got the interface going to the PE, core 2, core 5, and my trusty loopback. Alright, so now we're going to create the interface to core 3. EO3. Shut disk core 3. Okay, add 172.168.254.6. 255, 254. Okay. Now I with 50.123. Okay. I've got to do that on the core 5 link. Into O1, O2. That's 100 meg. Okay. That's my fingers cracking. Alright, now we do the router. Okay, net. Config. Alright, so okay, there we go. Run. Okay, so EO3 with the bandwidth link, core 5 with the bandwidth to 100 meg. The other two interfaces, they're standard. Now just to prove that they're showing up as 15100, we can go show int E03. Bloody hell. Cannot type tonight. Alright, so we look here, and there it is. 50,000 kilobits per second, which is 50 megabits metric, not binary, or whatever, the 1024 version. Otherwise it'd be 51,000 something, or thereabouts. Okay, and hey, 10,000 meg, that's not right. Ah, there it is. That's 100 meg. There you go. See, 100,000, and that just proves also that the core 1 to core 2 is on a 10 meg link. Cool. Okay, so we're done there. Okay, back. Just right, make sure. Now I'll go to GNS3 for a second, and I will add the link. Where do I have it on the notes? Core 3. Did I actually have it on core 3? EO2, okay. 3, 10, 2, okay. I'll move that there, make it more visual. GNS3 admins, developers, please change the link designators to be in line with the actual line, like it is in the GNS3 web UI. It just makes so much easier to figure out which link is which, I should say. Okay, alright, so core 1 is configured. Let me bring back our console, and we will go to core 2. Okay, reference. Okay, T. Oh god. Okay, first let's do back to 0. And 1, 2, 6, 5, got 2. Okay, let's see. Shot. Let's come back to 1. Okay, add 178. 16254.1, 255, 255, 254. Okay, now I'm just going to point something out here. The reason I'm using /31s is primarily in most network topologies in provider space, you will find that they will use a /31 on a point-to-point link, just out of sheer sense of it. Especially in big businesses, I mean, you could actually be hitting a large pool of IP addresses and have very limited address space available to use. So using a /31 is actually very efficient, and if you do it the right way, you know where each link will be in a bit of logical sense. So anyway, let's keep on. First, let's want to make sure we can ping. Hold on. IPCDP. Neighbors. Hey, there we go. We are with core 1. Do show VPN 172 192.168.254.0. There we go. Okay, so the first one's just the up table going, hey, where the fuck are you? Oh, here I am. Cool, done. Alright, int EO1 shut disk link equal 3 IP and 172.168.254.4. Int EO2 IP and shut disk link to B2 IP and 172.168.255.2. Okay. That's it. So we're going to SPF1 net. Config. Okay, right. Okay, the MPLS LDP is up to LDP neighbor, and we can see we are connected with 255.1. That's the peer, and our local one. The TCP port, I'm assuming. So that's our that's the peer, and that is ours. Open received, uptime. Okay, so then we can go discovery, and we can see we are transmitting and receiving. On our EOO interface, that's going to call 1, and we're transmitting but not receiving on 1 and 2 because we don't have anything connected or set up. In the case of Core 2's PE interface, we don't have the router connected on the actual lab yet. I'm going to do a video on that tomorrow. Just keep a foot. Alright, so just to show we've got the routes, so we can ping the loopback 192.168.255.1 source 192.168.255.2. Yeah, there you go. Even though the MPLS LTP shows this is already connected anyway because they can speak to each other. Alright, so let's go to core 3. There we go. T, back to 0, and 192.168.255.3, 255.255.255. There we go. And short disk to core 2, and IP add 172.6.4.5. And IP add 172.168.4.8. 255, 255, 255, 254, and EO2. Test Cisco and IP and 172.168.4.7. Bandwidth 5123 and .3. IP add shell desk link to PE3. IP add 172.168.255 dot 4, 255, 255, 254. So that's OSPF1, match. Yes, IP area 0. Config. Now, I will mention, I haven't mentioned before, I'm doing a cheat way of configuring the OSPF. Using the network 0.0.0.0 255, 255, 255, 255 basically says you can match any network connected to this device and it will share the routes that are connected to this device and known to this device to the other neighbors. So it will share all its connected interfaces to the other connected routers, so that rather than manually typing in the network network IDs effectively of each interface, which would be a pain in the backside, would add like 3 or 4 more lines of config. I can just do this and it's done now. And as we see, we saw a neighbor change and got the 2 neighbors. So we go like this, show route OSPF, and we can see the router 1 and router 2. Now this will be, now this should be telling us we should be going everything except for .2, we should be going via EO2, and that's because the bandwidth, and we can see that by the metrics here and here. So metrics here is basically saying it's faster to go from call 3 to call 1 directly, as it's a 50 meg link, than it is to go via call 2. Now I could have configured the links between call 1 and call 2 and call 2 and call 3 to be 50 megs and say this direct one would be 25. In theory, it would still go via call 2 and call 1. And OSPF database, and we can see our links. Cool. Alright. LSLTP neighbors. Okay, so we've got the P for call 2, P for call 1. Awesome. Discovery And we can see we're getting a transmit and receive on 00 and on 02. Now if we go back to core 2, discovery, we are now getting a transmit and receive on 00 and 01. Alright, let's go to core 4. Okay. Alright, so T integer back 0, I could add 192.168.255.4, 255.255. Yeah, okay, there we go. Shut desk to core 3. I could add 172.164.9, 172.168. That should work. There we go. 201. Then shut desk link to core 5. IP and 172.168.254, sorry, dot 10. And int VO2. Shut desk link to PE4. I can add 172.168.255.6, 255.255.4, and exit without F1 net 0. AKLS LDP config, and there we go. Alright, so there we go. We can see the route table is getting a bit bigger now. Now they're all going via core 3, obviously. So we go trace 192.168.255.1 source 5.4, and here we have an MPLS label, exactly what we're looking for. Now, go here, show my assigned. Now, if you noticed, EO3 is 172.16.254.6, which, if you look at core 4, 172.16.254.6, so it's going core 4 through core 3, core 1. It's not going via core 2. I don't like that. I'm going to change it. I'm just changing the notes. I go to core 2. Going to change that bandwidth to 50 meg there. Okay, so core T. Okay, now I'll go to also, no, core 2, there we go, that one, and then I'm going to change to core 3 as well. and EO1. Oh, shoot. Okay, so then we go here. T is EO3. Bandwidth 50. Bandwidth 25. Make it 25 meg. And then we go to EO1. And bang. Now show IP route. Okay, we go here. Now, let's have a look here. One is going via .6 still. The math. Okay. 50 meg wasn't enough to change it, I don't think. Yeah. Alright, so I've got core 1, T, and EO3, and then with 2500. Core 3, show interface EO2. Okay, that's why. T and EO2, bandwidth 53. Now, if I do this, okay, I might need to T and EO2 show. Okay. Now, there we go. Now I go no shot. Okay, that is up. Good. There we go. So we can see now it's going from core 3 to core 2, then core 1, and we've got 2 MPLS labels. So, MPLS label, range, nope, okay. Forwarding table. Okay, so this is the forwarding labels. So any label, local, outgoing, and it's pop. This is an acknowledgement hop to the next interface. Alright, so one more to go. Core 5. And there we go. There we go. Shot. Disk 1, and we add 172.6.3, and this is 3. Yeah, I did. Okay. That 102.168.25 dot. That's not correct. What have I done here? This should be dot 8. Okay. Is it one? Let's zero. Identify those. 0. Fuck. Alright, there we go. From EO and EO1. And there's the LDPs. Right, okay, so now this will be interesting. Let's go call 4. Okay, so include 9268 but 255.1. Okay, alright, so now we can see that to .1 it's going via .11, which is core 5. Now if we go back here, previously it was going via .8, which was core 3, and then go core 2, core 1, but now, so if we go trace, now it's showing different values here, and the simple answer is it's got 2 ways it can go. It can go via .8 or it can go via .11. So if we look here, the routes are the same. So when you pin, the Cisco device will go, okay, I can go this way or I can go this way. And it will show that in the output of the trace route. So we look back here, where it is. So we're going via .8, and this one's going via .11, then the second hop, which is .2, which is the EO2 interface on core 1, and you've got .6, which is actually core 3. Okay, something's going on here. Show routes. we have an interesting dilemma here. It's got here the same route, two different routes, going via .4 and .6. Alright, that's something for another day. Alright, just make sure it's saved. Right. Alright, since I'm a little bit bored, I'm going to create the PE for P1. Change host name, P1. Now config EO1 EO. Okay. Start it up. Let's bring it over. Good thing about these ones is that they load really fast, which is quite handy. Okay, so P1, there we go. Int zero, we should do a little bit first. IP add 126.254.1.5. IP add 126.255.254. .1 damas. Okay. Okay. 1, 2, there we go. Now I'm going to create the VRS. So we've got two. I'm going to make cast A and cast B. Alright, so VRF cast A. RD6502 1 and route target 6502 100. Okay. Now VRF cast B. Is 5.3 1. Route target both 5.3 100. Alright. So the route distinguisher. Now, usually you would have it a ASN, so autonomous number, and you'll have site ID is the usual way of doing it. But I found a lot of different articles had the same RD across the board for each PE. Now, I don't really like that simply because each site is different. So what we're going to do is I'm going to play and have a try and see how it works with the RD for P1 being colon 1, P2 will be colon 2, and so on. Alright, now let's get to the funky stuff. Now, rather than using two separate physical interfaces, we're going to use one interface but split into two using sub-interfaces. So let's go T, empty, go, no shut, and EO01, RDVO forwarding, class A, I can add 172.16.10.1. Oh, yes, cap dot 10. There we go. Then 0.02. Okay, so what we've done there is basically explained in this text here. The computing and IP routing on a LAN sub-interface is only allowed if that interface is already configured as part of an IEEE 802.10, IEEE 802.1q or ISL VLAN. So you have to assign VLAN, and when we do that with the encapsulation .1q10 and .1q20. So this is VLAN 10 and VLAN 20. So tomorrow we'll actually do the remainder of P's and the breakout switches. I'll show how to set those up. And remember, these are the viral images, so don't ask where to get them. Google is your friend. But yeah, these will apply to pretty much all of them, including CSRs. So let me finish this up. That part's done. So now we go to routes SPF1, which is you have separated each one as well. So you've got your base routing instance of SPF. This talks to the MPLS network. This is still part of the MPLS network. This is our provider edge. So this is where pretty much all labels go to die. Well, actually, correction. Labels go to die at the penultimate hop, which would be in this case core 1. Alright, so we go net 172.1.0.0.1. There is 0. And there we go. Hell. Now we do the read back. Bingo, config, and then there's the LDP. Route 10, SPF 10 VRF stay. Now I'm keeping it straightforward, so the OSPF process study is the same as the VLAN for custody. It just saves the brain a little bit. So here we're going to put net 172.168.10.0. There, that's 10. and then it's route OSPF20 ERF cast B, and that brings me to 16.20.0 area 20. Now, I'm just going to do BGP config, but it's not going to completely do everything because with another P it's basically going to be useless. So what would happen here is we create the BGP config, and then we would redistribute routes from the two VRF OSPF instances and BGP. And we'll do that tomorrow because it's getting late and I need to get my kids' lunches ready for tomorrow for school. Alright, so this is router BGP 65100, neighbor 168, 254, remote, yes, 100. And I'm just going to do it for the 4 other neighbours we will have, and then I'm going to do the other important part, update source, that's 0, 3, 4, 5, there we go, address, family, VPN v4, neighbor, 192.6.2, activate, and reactivate, for activate, bingo, okay, that's done. So we can have a look, section CCNP. Now we can see, well, that's correct there, and it's actually sending community extended. Now I believe this is so that the routing route targets and will actually import and export correctly when you do the redistribution. Now, obviously, with redistribution, you're able to fudge it with filters and route maps to adjust how you want, or what you want actually passing through. Now, generally speaking, the customer edge should be doing this, not the PE. The PE wants to keep it as simple as possible. On a more advanced contract, you might find that they will actually do the filtering on the PE side versus the CE side. Depends on how big the customer is, I guess, and how big the contractor is. Okay, so we go showing like the OSPF. Now we don't have the critical one. We go show IP OSPF. Notice we don't have the VRF routes here. They will not show up. Now, here's the other thing. Let's have a look. So let's go and try and ping core 4, which is that one. Source 192.6.4.1. Oh, okay. Yeah, okay. I can't type. Now go trace source 192.6.4.1. So we can see it going to call 1, and then we're going to dot 3. Now dot 3 should be call 5. Signed, and there it is. So it's going by call 5 to call 1, which is the expected way. Because if we look here, the cost is 11. Now, the path, so we've got a 10 meg, 100 meg, 10 meg. So it's 101, sorry, 10 and 1 to get to its location. Now, if you go to call 1, if you look here, so dot 4 is via dot 3. So that's call 5. However, if you're going to 3, it's actually via dot 1, as it's the closest way to do it. Even though it's a 100 meg link between 1 and 5, it's still 2 10 meg links between 5 and 4 and 4 and 3, whereas 1 to 2 is 50. But I think we changed to 3 as well. 1.01. Oh, no, we did. Okay, so it's 10 meg link there. Okay, all right. So we're done. MPLS LV discover. Just the one. Show MPLS LV discover. PE. Core 2. Core 3. Core 5. Core 3. So there we go. Okay. Sorry. Right, I'm going to leave it there. Tomorrow I will run through the 4 other Ps, and then I'll go through the actual configuring of or finalizing the configuration for the layer 3 VPN, and I will also set up a couple of Cs across the board just to show it all working, and we'll also do some Wireshark just to prove it's actually working. Alright, on that note, I am Heath Carruthers from alphahpg.com. Thank you for watching, and I'll see you next time. Ciao. If I can find this thing to stop. See ya.